Good morning, Assalamu alaikum students. We are going to discuss today intermolecular forces, that is topic number 4.4. Intermolecular forces. Inter means in between. Inter means in between. Okay, before that we were discussing about the covalent bond, and covalent bond is the mutual sharing of electrons. Fine. Now if a covalent bond occur between the same atoms or similar atoms, it means they are sharing equal electron pairs. Obviously they will exert the same force of attraction. Such a covalent bond will be called as non-polar covalent bond. The sharing of electron pairs occur between two identical atoms. Such a bond will be called as non-polar covalent bond. For example, if you take the example of hydrogen atom with the hydrogen, oxygen atom with the oxygen, fine, nitrogen atom with the nitrogen, these all are non-polar covalent bonds. On the other hand, if we talk about when we have the covalent bonding between two different atoms, fine, two different atoms, they are sharing the electron pair, such type of bonding is called as polar covalent bond. Fine. If you want to see the example, it is like HCl, hydrochloric acid, HCl. This is the interaction between two different atoms, hydrogen and chlorine. Fine, they are sharing the electrons, the dash is showing the covalent bond, but this type of covalent bonding is called as polar covalent bond. Is that clear? Okay, discussing about it, there are some other types of covalent bonding too. One of them is dipole-dipole interaction and other is hydrogen bonding. First of all, dipole-dipole interaction. Fine. What happens in the dipole-dipole interaction? The there creates the induction of polarity. Polarity means there will be created the positive and the negative charges. Fine. The slightly negative end of polar molecule is weakly attracted to the positive end of the other molecule, and such forces of attraction are called as dipole-dipole interactions. Fine. As you can see above, hydrogen and chlorine. Hydrogen has a slightly positive charge, chlorine has a slightly negative charge. It means they are having the polarity, the polar molecule, and the interaction will be called as dipole-dipole interaction. Now comes the topic hydrogen bonding. Molecules in which hydrogen is covalently bonded to a very electronegative atom. You all already know about the electronegative atoms. Fine. Now this hydrogen bonding is specifically based on the bonding between hydrogen and a highly electronegative atom. Fine. Now look at the diagram. The interaction of a highly electron deficient hydrogen, as you know, hydrogen has only one electron, so it is a highly electron deficient hydrogen, and lone pair on a nearby electron negative atom such as oxygen, nitrogen, fluorine. They are normally has the high electronegativities. Such a phenomenon or such a bonding is called as hydrogen bonding. Now look at the water molecule, hydrogen, two hydrogen bonded to the two lone pairs of oxygen. Fine. Now look at it, everyone is making a bond with other water molecules, and this type of bonding is called as hydrogen bonding. Fine. The applications of such a bonding are many, and they are important in determining properties of biological molecules such as proteins, DNA. We use this bonding. Even the adhesive action of paints and dyes is developed due to this hydrogen bonding. Then comes the next topic, and this is the last topic of the chapter number 2, that is topic number 4.4, nature of the bonding and its properties. As we know, we have discussed the two types of bonding. The first one was the ionic bonding. The ionic bonding, what is it? Compounds that consist of ions joined by electrostatic forces and they create ions. That is why they will be called as ionic compounds. Such compounds are crystalline solids at room temperature. They are crystalline solids even at room temperature. Now to take let us discuss the example. First of all, NaCl, sodium chloride, that is a table salt, NaCl. Every sodium atom, each sodium ion is surrounded by how many? 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. Fine. If we take a look at the structure of cesium chloride, fine, what happens in it? The structure is a bit different from the NaCl. Each cesium ion is surrounded by 8 chloride ions, and each chloride ion is surrounded by 8 cesium ions. So in the crystals of such ions, they have a strong attraction because of tightly packed structure. That is why they are very stable. and the ionic compound, that is why have high melting points. Now there comes a short question, a scientific question that normally comes in the board paper too. They ask, ionic compounds have high melting points, why? So you have to tell them, as they have the crystalline structure even at room temperature, that is why they are very stable, and they have high melting points. For example, the structure of NaCl, you have to draw the structure of NaCl, and you have to tell each sodium is surrounded by 6 chloride ions and each chloride ion is surrounded by 6 sodium ions. Fine. Furthermore, one more point I want to tell you, that is what, the ionic compounds actually conduct electricity. Why? As they get melted, there is a charge on sodium and there is a charge on chloride ion. The positive charge on sodium and chloride ion has a negative charge. If voltage is applied, the sodium ion start moving towards the negative electrode. Same time, chloride ion start moving towards the positive electrode. Fine. What happens by the movement or the flow of electrons? There is a flow of electricity. Thank you.